Atención. Thank you. All right, the recording is on. Show me some of that professional courtesy. I will. Hey, where's my Coke at?
I got a dub in my bag.
Nah, I had some this morning. Thank you. And I had a lot of good stuff. So, here's our objective. Oh, I don't like this ball.
What the heck?
It's too squishy weird.
Squishy weird.
Yeah, I
It's
know.
like super tender. It's like.
Is it flush?
What do you mean? Yeah, it's stressful.
Okay, moving on. Okay, here we go. Let's talk about the limit for a constant first. The limit of a constant. Here's the form. Can you guys read that okay? I try to blow it up a little bit.
Hey.
Let me just rewrite it for you. The limit, oops, I don't want that part of it. Oh well. The limit as x approaches a for some constant c will just be equal to c. So if they're asking for like the limit of as x approaches 5 where the function is just 7, then the answer is 7. Now, let me show you graphically because I think a lot of us are very visual. Okay, I can hold
No,
on.
just say like a limit of just the numbers.
Right, a constant.
Don't do like limit of like 7.
So like, if my function is, I should say function, if my constant is 12, then the limit as x approaches, actually, the limit as x approaches any value would still just be that constant number.
Even negatives?
Even negatives. It doesn't matter because here, so let me show you. I'll just do this. How about that? So someone just give me a constant, not too big.
13. So 2.
4.
How about
2.
4 is good. 1, 2, 3, 4. If I was going to graph the constant 4, I'm going to get just a line that does this, correct? So if I choose x to, if I ask you to find the limit as x approaches any x value, doesn't matter what it is, what will y be approaching? The same constant, doesn't it? So if I said, hey, you know what? Find the limit as x approaches 4, then that's just going to be 4. Because it's that the y value is always that number. Does that make sense?
Yeah.
So if I ask ya for oh, that's not what I wanted. Go back. This is what I wanted. You would say 8. 8 is correct. What if I said, hey, you know what? I want you to find me the limit -9. You would say?
-9.
What if I said as it approaches 6?
-9.
What about 8?
-9.
What about 18?
-9.
You get the point? The constant is just something. It's funny. It sounded good, huh? The constant is just a straight line right across on that y value all the time. So it will always do that.
Oh.
Questions? Questions on the limit for a constant? No? Okay. Okay. Do you guys remember the identity function?
No.
The identity function? Anybody remember the identity function?
Anything times 1 is itself.
That's the identity property.
Dang it.
But we're looking for the function. And I think you guys probably saw this back in 7th grade, maybe 8th grade for most of you guys. Okay? And it's the simple function y equals x. Right? Y equals x is called the identity function.
It's like a parent function.
Yeah. But this one has special, I said 2, not 4. But okay. See, I walked twice, so I got twice. What's nice about the identity function, now, if you guys remember, that's the one that kind of helps us see if two functions are inverses of each other, right? You always get back the identity function when you plug one into the other. What's nice about the identity function, y equals x, or f of x equals x, whatever you want to call it, is that when x is 1, what's y? It's also 1, right? If x is 2, what's y? 2. If x is -3, what's y? So the identity function has that
Not to scale.
those specific, yeah, definitely not to scale. Those type of properties to it. So that means that if I want to find the limit of the identity function, and we're just going to call it x. As x approaches any value of a, it's also just going to equal a. So if I say, hey, what's the limit as x approaches 4? You're going to say 4. Because for every x, it has the same y value. Questions? There's a question on the floor. Special courtesy. Taurus. Go ahead. Yeah, let me just reiterate that. See how when I have the line y equals x, if I put x 1 in for x, I get 1 out, right? If I put in 2, I get out 2. So they always match that way. This specific function itself is always matched with its corresponding y. So if I'm approaching this, I'm going to get that. If I'm approaching this specific x, I know that the y matches it as well. Now, if we change the slope of it, then that's different, right? If this becomes 2x, now everything is different. But this is the identity function we're talking about, which happens to be the x function, and that's what we're talking about in this case. So as I'm approaching any number, it should be matched up with the equivalent y value. Okay? So what would be the limit of this function as x approaches 2? What about the square root of 2?
Square root of 2.
Good.
Whoa.
Good.
I could really go for some soup.
It's too hot for soup. It's supposed to be 100 today.
Really? That's a good thing I turned on one of my ACs.
It's okay, your classroom's freezing.
Oh, I hope. We just turned it on, and I wasn't going to.
Thank
That's
you.
gonna check.
Where'd you get this?
So thirsty.
Me too.
Someone pay me attention. No, I drank like half of this already.
Where's your big one?
Home.
Oh no, you're hydro.
I wish we had like those fountains.
She just wanted to taste better.
I wish I had like the fountains where you put your water.
They're expensive. We thought about buying them. They're really expensive.
What is it?
There's these machines you can add to your sink, and then you can put your water bottle in it. It'll put filtered water in it. Clean. And they put them on, oh, you know who has them? Sabar Elementary. My little kids go have them.
There's one in the athletic hallway.
Okay.
Athletic hallway.
I can't drink. I'm like half the wine.
She made it
Weird.
weird.
All of very good too much juice and not enough coconut.
So we've got a little experiment here. Okay. Let's try to find. Let's look for the limit as x approaches, I don't know, 3. But we're going to call the function x plus 2.
Is it 5?
We're going to call it x plus 2, okay? So how would we go about this? What's our function? X plus 2. So let's start by graphing that, yeah?
Sure.
So let's see how. Where'd you go? Here you go. I just totally missed it.
I almost brought my charger today.
Are you live?
Yes, we are.
Thank you.
So what was our function? X plus 2 or x plus 3? X plus 2? Alright, so I can graph that. So here's my function. Thank you very mucho. Thank you. So here's my function. I'm looking for the limit as x approaches 3. So here is 3. What is the y value that I'm approaching? What is it? It's 5? Okay, thanks for clarifying. So we found that it's approaching 5, right? Well, let me think about this real quick. What would the limit as, you guys ready?
Yeah.
What would the limit of x be as x approaches 3?
3.
How much?
4. I'm sorry. I was throwing out a number.
Think back to the identity function. What would the limit of x be as x approaches 3? It would be 3. What would the limit of 2 be as x approaches 3?
2 because of the constant.
Because it's a constant, it would be 2. What is 3 plus 2? 5.
What's the more difficult?
So, just for you,
Thank you.
if you're trying to find the limit for two functions that are being added, you could just add the limits of each one individually as well. Okay? So, here's your next formula. And I'll try to... I wanted to... Let's see if I can make this work. Is that good?
You can't.
So, if I'm looking for the limit as x approaches something, and I have the sum of two functions, I can just add the two limits separately as well. Sometimes that's just easier to do. Yeah? Yeah. Oh, someone want to pick up their airplane, please?
That classroom with all the tissues is so cold.
It is. There's no bodies in there. Are we good with this slide? Okay, thank you. So, what is the limit of this bad boy right here?
Instead of negative 3, is it 13?
What's the limit here? Miss Campbell, what is the limit here? Joseph? What?
Why does it keep jumping?
Keep moving.
Oh, yeah.
I'm not gonna. What would you get? 13 is correct. Good job. 13 is correct. The limit as the function on x, as x approaches negative 3, is going to be negative 3 because of the identity function. 16 is a constant. So what's the limit as x approaches negative 3 on 16? 16. Combine them, you get 13. FYI, the same is true for the differences. I can just take... I tried a little too hard on that one. Shut up, dude. So if you have the difference of two functions, then you can just subtract your two limits separately as well. Okay? I'm not doing anything. Commentate.
Oh, wait, no.
Rock?
My
Wait, there's more.
She says chunkus, chunkiness,
Chunkiness.
chunkiness, chunkiness.
You okay?
No, she's dying.
Yeah, you know what else I'm doing today?
Progress report.
Wait.
That means I'm not going home for a while.
Yo. Did you put it in chapter? You're gonna put it in chapter 26 for stats?
26 is more like could be a given.
Really?
Yeah. Because all I really care about people doing is the homework. I don't care if you get 100. But there's some in there that I don't want you to do. All I care about doing for stats is being able to do an interval on the slope. Not when they say, hey, what about this specific sample? Okay?
So is there anything 10 for stats?
Yeah, it'll probably be 25 tests.
Oh.
And then 26, if people did the whole thing, it doesn't have to be 100, you'll get the points for that. Okay? Alright. Try this, please. Go, 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 go. Not my Richie! Not my Richie!
Oh, you're gonna get that stuck in my head now.
Para bailar la bamba. Para bailar la bamba se necesita una poca de gracia.
Have you seen La Bamba?
What?
Have you seen La Bamba?
Did you not hear me cry? No, not my Richie.
My
Not my
No,
Richie.
it makes me laugh.
Richie Valens.
I cried.
My
Shut
sister,
up.
my sister
Really?
she goes, not my Richie. Take, what's his name? What's the brother's name again?
I don't remember. I don't
Or
remember.
she's gonna say, wait, hold up.
There's this old movie.
Buzz Buster.
I don't know, but they're like, take him instead, take him instead. I'm my Richie.
Look at how they spell my name. Annis. A-N-N-I.
Very nice. Question goes to. You looked at me. Go. 5. 5.
5.
That was one. 5. So, I can find limits by adding them if it's the sum of two functions. I can do the difference of two functions. I can also do the product of two functions.
Booyakasha.
So even if I'm multiplying two, I can find their two separate limits, and I can multiply the two. Anybody need this?
No, the paper cloud's back on here?
I can change it.
Yeah.
Anybody want that up there?
It's the same thing, we have to change the sign to it.
Okay then.
Munoz,
can change it.
Munoz.
Exact same as the other one, but it's just add a dot. It's a dot. Have you seen that video? Dude's like yelling at the girl. He's like making it like it's so weird.
Maybe you just want to charge it so it's 100%. You can let it sit there overnight.
Why?
Oh, that's what you said. Are we good? Okay, try this. Try this, please. You getting it? Dallas, what's the limit here?
I can tell you.
Good job. negative 70 is absolutely correct. The limit of a monomial.
I don't want to write that down.
The limit of a monomial.
Monomial?
Yes.
You know what a monomial is?
Wait, so is that n
It's not a
the
binary.
sub?
Touche.
Is that the sub of b?
What's up?
That first.
Let me, thank you. So let me just simplify this for you.
And orange.
The one we just did a minute ago, what was it, 3x or what, 7x, negative 7x?
Negative 10x.
Negative 10x? That was a monomial. What you could have done was simply plug in the value, which I think most of you guys did, right? And then multiply. So that's what this is also saying. If you do have an exponent of some sort, just plug in the x value that they're asking you to approach, simplify it, and then you'll get your value. Understand this, most of the time, our functions are smooth and continuous, correct? So when we evaluate the limit that they're asking to us to, the x value they're asking us to approach, plugging that in will tell us what it really is. But that's also what it's approaching. The only times that we're really ever gonna have problems is when there's holes there. So the only times you really wanna be cautious is when you're gonna have some type of rational function, okay? So it doesn't matter if it's a monomial, or as the next slide is gonna be, whether it's a binomial, polynomial, whatever it is, just plug it in. It should give you the value. If it's a rational function, then we're gonna have some things to worry about. And we'll talk about that in a second, okay? So, for example, here's this. What's my limit gonna be here?
Is it?
Negative 57.
What's 2 cubed?
Whatever 8 times 7 is. I can't times that fast.
Yeah, negative 56.
There you go. Boom shakalaka.
It goes
Okay?
5, 6, 7.
You're supposed to be a math teacher?
Man, I'm a good mathematician. I think I've said that to you guys, right?
Yeah.
But I'm a poor arithmetician. When I was being taught to add, subtract, multiply, divide, it was this whole learning, this
What
whole
was your
learning
hardest
experience is
one?
what it's called. And it didn't care about speed. It's like, do you understand what's happening? I'm like, yeah, but I know what they are.
Which one was your hardest one to learn?
I still don't know them. Did I just not say that
I
right
know,
now?
I meant like,
Like what? Times table?
Yeah, Tom said this. Most of them I could do. Once I get to like 7s, 8s, 7s and 8s, I think are the hardest for me. Because 9s, I just use my fingers with that little
oh,
ruler.
yeah, 49, and then
And
after
then-
that.
Unless it's times 11.
See, oh yeah, 11's not bad.
I'm a good whatever you said. Yeah.
Okay,
But not math.
so what's the limit as x approaches 2 for this polynomial?
I know it. Give me a second.
12 minus 10 plus 3.
Sound like Chewbacca.
73.
That's above my
That's a
pay
plus
grade.
to your mind. Yeah.
I got a 61.
What is it?
61.
61 is
What?
correct.
Why did I get 33?
I need a calculator.
Again, take a look at this problem. We don't have issues with rational exponents here, right? So if you plug in the value, we should get what it equals to, which should also be the same as what it's approaching.
Yeah.
And with the limit, that's what we care about. Okay? Any
Wait,
questions
can you
so
do
far?
it? Can you do it?
Can we do it?
Yeah, I just want to see.
What's 6 times 7? What is 6 times 7? Wait a minute, that's not 6.
That's 6.
Math teachers. What's 7 times 8?
56.
56?
Yeah.
What is 3 times 4? 12? And negative 5 times 2 is a negative 10. Plus 3. So we got what? 5 plus 56? Yeah. 61. Okay? So even though that's what it's equal to, that's also what the function will approach on both sides.
Wait, 36.
That's only
That's a
because our
56, not a
function
36.
is smooth and continuous. Well, not smooth.
What do they say for?
What's that on?
It's
I'm so excited.
the 2 words for calculus. Continuous.
always told smooth and continuous.
There's another word for smooth.
There's just another one, and I can't think of it because it depends who's doing it. What slide is this? Oh, there it is. Okay, so the limit of a power. Same deal, right? Do I have to worry about having undefined business going on here?
No.
No. So if I plug in a 4, I should be just fine. 3 times 4 is
12.
12. 12 take away 5 is
7.
7 to the third is
243.
big number.
Big number. 1.
343.
All right.
343. So the limit of 3x minus 5 to the third as x approaches 4 is simply what the value is equal to. Okay? So it'll be 343.
If you're, so that's like a, right on the graph it goes like this.
It'll be. It's a Q function, so it'll look something like this.
Okay.
Do you know what's after
I
I'm
was doing the
still
homework and it had,
I
got it right.
The analytic geometry?
the trig?
Analytic geometry. Or, yes, analytic trig. I think it was called analytic geometry. Yeah, it's the 5 with the rules and the.
Never got it.
I didn't get that till I was in college.
I know, I really hope
That
once I
makes
go
me
to
feel
college, math is like,
I didn't get that till I was in college.
actually, I heard stories
Okay.
about Mr. Alshaw's son.
Okay, the limit of a root. The limit of a root. What this is saying is that you can do the same thing as before.
This should be pretty easy.
just plug it in.
Yeah.
What if you have an asymptote underneath it?
This will be. This isn't going to be asymptotic.
Well, what if you have like this on the top and then it's like divided by like
Those you're talking
x
rational
minus
functions.
6?
That's where we have issues with rational functions because irrational functions might produce asymptotes, or they might produce poles on this function.
So regular ones are always going to be the answer.
Pretty much. I only really want to be careful with rational functions.
So we can just like.
Now, of course, also I don't want to end up with a negative number here because I can't have imaginary. Either, right?
That's
So we're just doing like algebra for this part. It's just like, oh, find this. And
this
then
one's not really asymptotic.
Yeah. And yeah, the roots are not asymptotic.
They go to
Yeah, very slowly.
yeah, but they get there.
But they'll get there. Very slowly. Very carefully.
Wait, is the L just the X?
L represents the limit. So what it's saying is you can find the limit and then take the nth root of it. Just like we've been doing. Okay? So here we go. Here's an example. I can try to find the limit of this business and then take the square root of it. Or I can just plug in that negative 1. Negative 1 squared is 1. 1 times 6 is 6. Minus 2. So the square root of 2 would be my limit. I'm approaching whatever radical 2 is. Ladies and gentlemen.
it's a triangle.
Okay? Questions there?
That would be bad. It's a little too close.
Here's where it starts to get
Disgusting.
Say here.
interesting was going to be the word.
Oh, disgusting is better.
That's why I should write this down. Does this have 2 answers?
Disgusting. Say here.
Palmitate, people.
This is where limits.
Palmitate.
Write it down.
Just like I can multiply them, I can subtract them, I can add them, I can also divide my two limits separately. As long as I'm not going towards 0. So if you see that the a value is going to make your denominator equal 0, then that's not okay.
Oh, well that's just
But
like.
as long as it's not going to 0 the denominator, then I could divide the two and I would be just fine.
Okay.
Good?
I thought it was gonna be super ridiculous.
Sounded like the lady from, yeah, that lady from Monsters Inc.
So. I'm watching you. He did it. I just repeated it. sorry.
The really
Sorry.
good,
What the heck?
Finding Nemo, the little. You made me eat. You made me eat.
Okay. So check this out. Here's what I mean by that. Here's what I mean. Thank you. Thank you. Notice that if I plug in a 2, 2 times 3 is 6. 6 minus 5 is 1. That's not 0. Right? I'm okay. I can find the limits in it separately and then simply divide them.
It might not be zero.
Green light.
What if it's like
Now, if I was trying to approach 5/3,
Then you'd have a problem.
then I'd have a problem, right? Because if I'm looking for the limit as x approaches 5/3, 5/3 would make my denominator 0. I can't just plug in. I'd have to use something, some other tools like,
Graphing, the table.
well, hopefully, I can use my factoring tricks and do some removable discontinuity business. Remember that is? Or I can just graph it, or I can look at the tables. But there are other things to do, okay? But in this case, I don't have to worry about it. I'm not going to 0. We're good to go. Right? So in this case, what will we get?
-3.
Booyah, done.
Booyaka.
I just totally missed the test.
Oh, yeah.
I'm glad I didn't,
Nice and
you know, one of those things.
Don't know what I did. I see.
Woo!
So trash.
I didn't put the at a glance. No, I did. I probably thought it was too much.
Is it just 3?
Yeah, -3, right?
No, positive.
Was it positive?
Wait. Yeah, it's positive.
It was a -3.
Oh, is it? No.
So the limit
Oh,
here
yeah. It's just negative.
Or
Sorry.
minus
Sorry.
is 1, correct? That's what we said? And then we got 2 squared, which is 4. Take away 8 minus 1. Yeah,
Plus 1.
yeah. That's what I meant. No, what I meant. Not what I said.
So failed the test. Stop it. Oh, what's that from?
Beavis and Butthead.
Oh, yeah.
Oh god.
Oh yeah.
I love that.
That's how
Did you know that Endgame, you know how it's doing just last night? $16 million
Wow, that's awesome.
I could be a troll.
Time for some challenge.
Got it.
Please no. Please no.
Please find me the limit of this piecewise function as x approaches 1. Sorry. 1, not -1. 1 from the negative side.
Oh, I know what it is. Got it.
From the negative side, from the left.
Well.
From the negative side. What is it? Or not 1.
I know.
-1. Why -1?
Oh, if that's
Oh, is she crying in the fetal position over there? What happened?
She's giving me
You know? Why?
okay, so it says it's -1.
No professional courtesy, please.
Okay, I'd have to see. It's -1 because it says right next to it says if x is less than 1.
So if you take a look at our piecewise function, when x is less than 1, we're going to be, it's going to be a constant function.
Oh, that's a good source.
And if we're greater than or equal to 1, we're going to be whatever this is. Bleh. I don't even want to try to draw that.
It's just regular.
It'll be here,
It's just one.
right, at some point,
It's just a constant.
and then it'll have a piece this way, but it doesn't work because we're this piece, we're this part of it. So the other part. So it looks something like this, I think. So if I'm looking at the limit as x approaches 1 from the negative side, I'm getting closer, 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 always still to that same function. It's a constant function, therefore, negative 1. What is my limit as x approaches 1 from the positive side?
I know.
Cubed of what? It was one.
Cube root of
Positive one.
It's approaching what?
Well, yeah, cube
Positive one.
It's approaching a positive 1, correct?
what?
Because the cube root of 1.
Oh, it is.
Well, it's
You subs. So
we got 2 times 1, which is 2. 2 minus 1 is 1. The cube root of 1 is 1. Okay? So, question? What is the limit of
so that should be.
that function as x approaches 1?
That doesn't exist.
It does not exist.
It does not exist. Why does it not exist, Tara?
Because there's 2 points. Like, the things on top of each other, so you can't, like, it just doesn't exist.
You're a visual person. Go ahead. Thank you. You're not wrong.
Okay. Okay. Sorry. I just.
Why does the limit not exist?
It doesn't exist because there's a different limit for one coming out of the negative side and the positive.
Right. Exactly. So you're approaching 2 very different things from the left-hand side and the right-hand side. As Sarah pointed out, it's very obvious that we're not going to the same number here. Okay? Questions? Okay. Let's see what else I got. Oh.
I like that.
So this one is the boogeyman.
I like that.
We've already done a whole unit on rational functions, right? And there was methods that we did to try to get rid of the denominators, that discontinuity down there,
Oh yeah.
right? Okay, this is what we're saying. And what was that method? What did we do? We tried to make it just snack it. We tried to cancel that thing out of there, right?
Yeah.
So look, here we got, they say find the limit as x, for this function as x approaches 1. Notice that if I put 1 in the denominator, 1 minus 1 is 0.
Yeah.
That denominator is going to 0. I can't just simply go find the denominator, find the numerator, because it would be undefined.
Right.
So, because 1 minus 1 is 0.
I said right.
Oh, sorry. I thought you said y. So, we're going to refer back to our other tools when we're doing rational functions, and we're going to see if we can remove this discontinuity here. And the way we're going to go about it is by factoring. So, in the bottom, I still got x minus 1. Does the numerator factor?
Yes.
Yeah.
It's going to factor into x minus 1 and x plus 3? Is that correct?
Yes.
Cool. So check it out. Removable discontinuity. So, what's my limit going to be? 4 is correct. Well, we're still taking 1, plugging it in, right? 1 plus 3 makes 4. So the limit at x approaches 1 for this nastiness is 4. Does it equal 4? No, it approaches 4.
There's a hole.
Yeah, there'd be a hole there. Just like we had it. I'm feeling so relaxed. Questions on anything I've said? We're done for today.
But if it's not done, what happens?
What is what?
I know.
Most of the time they will be. I don't think they're going to do that to you right now. But if it's not, then you can always use your